Hello, my name is Alexi Casado, and this is my term project for 15112 at Carnegie Mellon University. Here I will be showing you what my project is and how it functions. Trussty is meant to be a truss simulator where the user inputs a set of parameters and the program calculates the forces within your truss's bars. It does this as well as calculates the stress in each bar, and it finds out whether or not your structure will collapse. To first introduce the concept, I will go over how one can manually calculate the bar forces in a truss. Here on the website Mathlino, you can see a basic truss, and it explains the method of joints. This method requires you to find the reaction forces in the supports, and from here you can find and calculate the bar forces by x and y equilibrium equations, which requires you to know the height and the length of the beams as well as the angles. The problem here is that oftentimes the user will have to test multiple joints before finding one that has the minimum amount of forces acting on it that is already calculated. After manually doing this, you are able to find the forces acting on other joints to eventually solve the connecting forces of a joint with more bars. The simulator acts as a way to calculate these much faster. So if you can see in the program, I use recursion to find different angles as well as to calculate the node. I recurse until I have found a bar that already has two found forces acting on it, and then it solves it by doing that. At the home page, the user can choose which truss they would like to use, which will change the way the forces are distributed throughout the truss. There's a choice between the Warren, the Pratt, and the Parker, which all have a different layout of connectors, and as I said, this changes the distribution of the forces. Once you click on your desired truss, you will be able to see the beam layout on the right. And you are also then able to hit continue, where you are brought to the next slide, which will prompt you for a choice of materials, with a choice of steel, iron, concrete, or wood. And from here you can also adjust the beam dimensions and decrease the width and the breadth of the beam, this slide will alter the stress analysis because it will find the maximum tensile and the maximum compressive stress that the truss can withhold, as well as affect the individual stresses within each beam. After hitting continue, you can change the length and the height, and also the amount of nodes. You can increase and decrease by clicking on the buttons. Once you hit continue, you are brought to this page where you're able to move the selected node with your right and left arrow keys, and based on that, you can also, once you've picked a node, you can increase or decrease the force that is acting on it, and you can go all the way up to 20,000 newtons. Once you've decided, you can do that on multiple nodes. Once you are satisfied, you hit continue, where it will bring you to the solve page, and it will solve for the forces. And this representation shows you the connector's two nodes, which is visualized here. So if it shows that it's on 0 and 5, you can see that on this picture by the 0 and 5. And the red bars here show you which ones have broken as a result of stress, and it lets you know whether or not your bridge has collapsed. And if you would like to try again, you can go pick some potentially stronger materials, for example, and increase the number of nodes if you would like. And if you set a very large, even if you set a very large force, you will still be able to see that your bridge has held. Thank you for listening, and I hope you enjoyed.